Hello friends, welcome to engineering tutorial. So we'll continue our discussion related to material science and engineering. So far we have discussed various concepts related to elastic and plastic behavior of materials and the basic concepts related to stress strain and their relationship and various associated things. So in this video we are going to discuss about another important concept, another important topic, which is basically associated with elastic materials. So certain phenomena, certain effects that are associated with elasticity. So some basic elastic effects. So far we have discussed the elastic and plastic behavior of solids. So basically what it says that if a body, a rigid body, not all bodies are perfectly rigid, but if a body is subjected to external deforming force and it undergoes change in its dimension, shape, size, bending angle or anything, if it undergoes change on the application of the deforming force, and as long as the deforming force is there, the change is there. But as soon as the deforming force is removed, if it returns back to its original shape and size, then it is called as elastic behavior. That means the deformation, the change in dimension is temporary in nature. As long as the deformation force is there, the external force is kept on, it's continuously applied, it stays in that particular deformed state, and as soon as the deforming force is removed, it returns back to its original shape and size. So this property of temporary deformation, that is called as elastic behavior. Plastic nature is when the deformation force is applied, the body undergoes a permanent transformation, okay, permanent deformation in dimension, whether it is length, breadth, height, or sliding angle, bending angle, or any kind of change in its dimension. And if it is permanent and it does not return back to its original shape and size even on the removal of the deformation force, that is plastic behavior, that is plasticity. So here also we discuss the concept of elastomers, which is hyperelasticity, where the elastic nature is very high, low Young's modulus, and it has no well-defined plastic region. So basically hyperelasticity is elastomers. So here, associated with these elastic materials, there are some basic elastic effects that come into play. So we'll discuss them one by one. First one is elastic after effect, okay. Then we have elastic fatigue and elastic hysteresis. So here first we'll discuss elastic after effect. So let us say we have an elastic material, let's say a rubber band or any elastic material we have. Suppose it is subjected to external stress, external force, some force is applied, okay. So as a result, this elastic material, it gets stretched. So this is the elastic material, then force is applied on it, it got stretched, okay. This is the stretching of the elastic material. Now as soon as the force is removed, the elastic material, it returns back to its original state, okay. This is the basic nature, the basic property of elasticity. Now here what happens is that in some cases the material, it almost instantly after the removal of force, it returns back to its original shape and size, almost immediately, instantly, okay, quickly. But in some cases it takes a lot of time, it takes a bit longer. Now depending upon the properties of different elastic materials, this lag, this time gap between removal of deformation force and the body returning back to its original shape and size, original state, this time gap can be different for different materials. All are elastic materials, but this time delay in returning back to their original state after the removal of deforming force, this can be different for different materials. Some regain their original state almost immediately, quickly, while some take a bit longer than others. Okay, so this time delay, this lag in regaining the original state by a body after the removal of the deforming force in case of an elastic material, that is called as elastic after effect. The delay, the lag in elastic materials in regaining their original state after the removal of the deforming force. That is the basic definition of elastic after effect. Okay, this time delay, this lag can be different for different elastic materials according to their composition, their nature, their chemical and physical characteristics, everything. So this is elastic after effect. Then we have elastic fatigue. Okay. Yes, elastic materials, they return back to their original state after the deforming force is removed. That is the property of elasticity. But if we continuously, repeatedly subject the elastic material to repeated alternate stress, continuously applying force in opposite direction, first we to and fro, up and down, continuously applying stress in opposite directions repeatedly, it ultimately breaks down. There is breakdown in the elastic material because ultimately it loses its strength. The material loses its strength because of alternative application of stress. This results in opposite strains, alternate strains in opposite directions. That's why there is loss of strength in the material, and the material, it finally breaks down. This breaking down of the material when subjected to alternative stress in opposite directions resulting in alternate strain is called as elastic fatigue. Okay, so let's say we have a material. Okay, first we stretch it in this direction, then again we stretch it in the opposite direction, then again stretching it in the opposite direction. It results in alternate stress and strain. Okay, alternate stress and strain, and finally the material, it snaps, it breaks down. Okay, because of alternate stresses resulting in alternate strains in opposite direction. This is called as elastic fatigue. Because strain is produced in opposite directions continuously, repeatedly. Because stress is applied in opposite directions repeatedly, strain is also produced in opposite direction. This continuous application of stress, repeated application of stress, results in the loss of strength of the material and it breaks down. This is called as elastic fatigue. Then is another important phenomena, which is elastic hysteresis. If you remember, when we discuss the stress strain curve of metals, there we discuss the concept of residual strain, permanent set. This is also a similar concept. Let us say we have, let's say, an elastic material and we subjected it to stress by increasing the force in one direction. Okay, in one direction we repeatedly increased the stress levels. Okay, we repeatedly increased the stress levels. So obviously the material, it will undergo strain. Okay, it will undergo strain. There will be a stress strain curve. So here what happens for the elastic material, when the stress is increased, okay, that is called as loading. When the stress is increased in one direction, it is called as loading. So during loading, that is increase in stress, the stress strain curve, it takes a certain path. In this case, it is OAB. During loading, loading means increase in stress, gradual increase in stress on the elastic material. That is called as loading. So during loading, the stress strain curve, the plot of stress strain, where stress is in y-axis, strain is in x-axis, it takes the path OAP. Okay? So when this is the stress during loading, the resultant strain is this one. Okay? Let's say this is sigma 1. Here this is epsilon 1, the strain during loading. But during unloading, okay, during unloading, that is when the stress is decreased. Unloading means decreasing the stress, okay, decreasing the stress gradually. First the stress is increased gradually, okay, then it is decreased gradually. That is from Fn and Fn minus 1 like that to F2, F1. The stress is, this is called increasing the stress gradually, that is called as loading. Increasing the stress. Decreasing the stress gradually, that is unloading. So what is observed is that the loading and unloading curves, they do not follow the exact path. The unloading curve does not retrace this OAB. Ideally it should be BAO, OAB, BAO. No, it takes the path BCO, which means that for the same stress levels during unloading, the strain is different. Let's call it E1 dash. Okay, the strain is different. So there is some permanent residual strain in the elastic material. For the same stress levels, during loading and unloading, the strain levels are different. During loading, it takes one value. During unloading, it takes another value. Okay, so this gap between the initial strain and the final strain during loading and unloading, this gap, this is called as residual strain. Okay, residual strain. So during loading, the stress strain curve is OAB. During unloading, that is decreasing the stress, it takes the curve BCO. It is different. So this gap is called as residual strain. So the same thing is there. The stress strain curves during loading and unloading, they are not in the same direction. They do not take the same path. They take different paths. The curves, they trace different paths. This is called as elastic hysteresis. And the shaded area, okay, the gray area here, the shaded area OABCO, it represents the energy lost during the loading and unloading cycle. Basically the loss of strength in the material during the loading and unloading cycle. So basically what is important here is that there is some residual strain left in the elastic material. It does not exactly return back to its original shape and size. There is some permanent deformation, some level of permanent deformation. It returns back but does not exactly return back to the original shape and size. There is some permanent residual strain there. So that is called as elastic hysteresis. Okay, so here we have discussed the three main important concepts. Elastic after effect, which is the delay of the elastic material to return back to the original shape and size. Elastic fatigue, which is the breaking of the material or snapping down of the material due to continuous repetitive application of stress in alternate opposite directions and the resulting strain. And elastic hysteresis is the residual strain left in the elastic material during the loading and unloading cycle. loading basically increasing stress and gradually unloading is decreasing stress gradually. Okay, so this is the thing.